Okay, so that's the difficulty. So now let's try to understand how we can resolve this. And we have partially covered this aspect in one of the previous lecture as well. So what's the very basic thing we could do? If we have this input image, we can represent this image at pixel level. All right, so pixel level means for each pixel, you have 3 different values if it's RGB image. And you can say that, okay, this pixel has red color, this pixel has green color. So that's like one very crude form of image representation. And you can, in fact, create your algorithm just using that representation. But let's see what are the issues. So let's say we just pick like 2 pixels and we say that, okay, this is like x-axis is pixel 1 and y-axis is pixel 2. And let's say we try to project like the value of that pixel on this axis and also on this axis. And let's try to simplify. Let's say it's not RGB, it's just grayscale. So grayscale, it's easier because RGB, it's already 3-dimensional, right? If we have to project it, it becomes a little bit complicated. So let's say it's a grayscale image, and this excuse me, this x-axis is representing the intensity of that pixel. So you know that in a grayscale image, pixel value could be between 0 to 255. And this x-axis over here, it's marking like what's the intensity of that pixel. For example, like this, one of the pixel of the motorcycle, let's say it's at this point, and the y-axis is intensity of pixel 2. So this is just showing 2 pixels. But if in your input image, let's say you have 1,000 of pixels, then you will have 1,000 of different dimensions. And you can again just generalize this idea from 2 pixels to a lot of pixels. So this will be your first pixel, depending upon what's the intensity of this pixel. And again, this is like another pixel coming from your image. So these two are like motorcycles. And these are some other images, which are, you can say, negative images. These are not motorcycles. And for the same set of pixels, the values of pixel intensity actually falls at this point for this image and at this point for this image. And we can try to plot like more such images. And what will happen is your these blue dots here, or the blue crosses, these belong to motorcycles, and the negative red are kind of non-motorcycles, negative motorcycles, negative images, right? So this is kind of your distribution. But if you will see, like, there is no way of knowing like which of these marks are actually motorcycle and which are not motorcycle. So you can't actually draw a very simple boundary which can divide these two. So that's the difficulty of pixel, and that's actually true as well, because your pixel color will change depending upon like the orientation, the lighting condition, a lot of different factors there. So clearly pixel-based representation is not good. Okay, so how can we improve this? So one simple step could be you can have feature representation, which is actually looking at parts of these images or parts of these objects. Okay, so parts could be, for example, you're looking at, let's say, handlebars, or you could be looking at wheels. And so right now, don't worry about how to actually extract wheels or how to extract handlebars, but just try to understand like we are moving from pixel level to concept level. Okay, so let's say our feature representation is focusing on these concepts. And now what we can do is, instead of the axis representing each pixel, these x's are actually representing these concepts. And now let's say x-axis is saying handlebar and y-axis is saying wheels. Then if you try to plot like different images, then what will happen is your images from motorbikes will see like they will have handlebars and they will have wheels. So they will fall over here. And then all the negative images, they won't have handlebars and they won't have wheels. Okay, you might have cars as well. In that case, your wheels will go way up, right? Because they might have 4 or more wheels here. And again, they won't have handlebars, so they might lie around this region somewhere. But again, you will be able to differentiate those images of cars or 4-wheelers with your motorcycles. So in this case, if you have such a plot, and again, this is just 2-dimensional, just 2 concepts, you might have like a lot of other concepts. It will be like n-dimensional space. But the good thing here is, if you just draw a line over here, then what you can say is, during test time, if I give you an image, depending upon like where that image lies, whether it's like towards this direction or this direction, you will be able to say this is a motorbike or not. Okay, so this is kind of a fine distribution which is discriminating, or which is helping you in discriminating between these two type of images.